Well, now section 6 here, factoring a difference of squares, is probably the easiest section of all the factoring that we're going to be tackling. But keep in mind, though, at the same time, it can also be very trying when they get as we get a little bit more complicated. But the premise is it's going to be very easy, very simple. Look at what we have. We need only two terms. Both terms must be perfect squares. So we've got to be able to recognize perfect squares. Let's write that down. Recognize perfect squares. And that's not just for our whole numbers, but that also includes the variables. What constitutes a perfect square when we're talking about variables? If a variable has an even exponent, it's a perfect square. More on that later. And the third thing that has to happen is that one of the terms has to be a negative. And what we're going to do is we're going to write this so that the minus sign is between the two terms. I'll show you what I mean by that when we get to it. But keep in mind that whenever you factor a difference of two squares, it will be two sets of parentheses, just like we've been getting before. Two binomials. Here it is, very simple. Start with your two sets of parentheses. X squared minus 25. Now, we're going to take the square root of the first term. What's the square root of x squared? That's right, it's x. Then we're going to take the square root of the last number. What's the square root of 25? Well, it's 5. Well, now, if you can handle this, I don't know. Here's the hard part. 1's plus and 1's minus. And you're done. And here's the reason why it works out this way. X times x, x squared. Positive 5 times negative 5, negative 25. But look what happens to the middle terms. I get positive 5x here. I'm going to get negative 5x here, and those middle terms end up canceling out. And that's all there is to it. So in number 2, when you factor it, start with your two sets of parentheses. The square root of n squared is n, so we start with n times n to get the n squared. The square root of 16 is 4, so we put 4 here and here. 1's plus and 1's minus. It doesn't matter which one's which, but you get n plus 4, n minus 4. In number 3, m plus 10, m minus 10. Number 4. By the way, we always look for a GCF first, right? Write that down. Very important. Always look for a GCF first. And if you do, remember what it's going to look like. You'll have the GCF and then times those two terms. So the binomial. So that's what it's going to look like if you have to factor out the GCF. Again, I'll show you what I mean by that in a few minutes. Looking at number 4, though, we don't have a GCF here, so we're going to start with two sets of parentheses. Take the square root of the first term. Well, the square root of 9x squared would be, well, we need 3x times 3x to get 9x squared. And the square root of 49 is 7. We're going to have 1 plus and 1 minus, and you're done. Number 5, start with two sets of parentheses. Now, the square root of x squared y squared. Now, is there a plus sign in here? No, it's x squared times y squared. So when we take the square root of that, we just get xy. So we'll need that here and here. The square root of a squared is a, so that goes here and here. 1's plus and 1's minus. Number 6 is prime. Here's the reason why, is because of that plus sign right there. Remember, all we're factoring in this entire chapter, it's got to be one of two things. It's going to be in the form of ax squared plus bx plus c, or it's going to be a difference of two squares. Now, does this fit in either of those two categories. No, it does not. And there's no GCF, so we don't have to worry about that. So it's prime. Number 7, is there a GCF? No, there is not. Is it a difference of two squares? Yes, it is. 4 is a perfect square. M squared is a perfect square. So is 81. So is n squared. There's a minus sign in between them, so that gives us a difference of two squares. So give me your two parentheses. Take the square root of the first term. What's the square root of 4m squared? That's right, it's 2m. So that goes in the first spot, both parentheses. What's the square root of 81n squared? It's 9n, so that goes in the second spot in both parentheses, 1's plus 1's minus. In number 8, make sure you keep the minus sign in between the two numbers. Now, normally we would want to write this in descending powers, if you remember that, right? But when we're talking about a difference of two squares, I want the minus sign in between the two numbers. I want to keep it just like it is. I don't want to write this negative x squared plus 64. I want the minus sign right where it is. So we're going to use our two sets of parentheses. Now the 64 is in the first spot, so the square root of it will go in the first spot. The square root of x squared will go in the second spot. 1 is plus and 1 is minus. Now the reason why it has to be written like this, I mean 8 plus x is the same thing as x plus 8. So these two things are the same thing. But 8 minus x and x minus 8 are not the same thing. This would not be the answer. We have to have the 8 minus the x. Go on to page 2. Now we're always going to look for a GCF first. And remember what that's going to look like. When you factor a GCF, you're going to have the GCF and times the number of terms that you have in the original problem. What's the GCF in number 10? Well, there's a 3 in common. Now, don't try to factor out the 3 and then give me two sets of parentheses. You're not going to go there. Why? Because when you factor a GCF, it's going to be the GCF and then divide out the 3. Well, the 3's cancel. You get x squared. Bring down the minus sign. 75 75 divided by 3 is 25. And now you have a difference of squares here. This is what's going to be broken up. Ignore the 3. X squared minus 25. That's a difference of squares, so that's going to be x plus 5, x minus 5. Bring down the 3, and now you're done. 11 is very similar, except there's a GCF of 2. So we're going to have 2 times the quantity, and it turns out to be x squared minus 25. Well, the x squared minus 25 is a difference of two squares. It gets broken down into x plus 5, x minus 5. Bring down the 2, and now you're done. Always look for a GCF first. And always, and when you have these two terms, make sure the minus sign, here's what I mean by having the minus sign between the two numbers. We need to rewrite number 12. How are we going to rewrite it? Well, I want the minus sign in between, so we're going to write this 2y squared minus 2. And now we're going to look for a GCF. What is it? Well, it's 2. So we're going to have 2 times the quantity. That's right, y squared minus 1. Y squared is a perfect square. 1 is a perfect square. It gets broken up into 2 parentheses. Y and y plus 1 and minus 1. Bring down the 2 and you're done. Number 13. What do you have in common? Let's go back to page 1 real quick. You know what? I don't think I scrolled down far enough. No, I didn't. Sorry about that. Let's go back to page 1 here. Look at number 9. I thought I was missing something here. In number 9, x to the 4th minus 1 is a difference of two squares. Remember, if it has an even exponent, it's a perfect square. So what's the square root of x to the 4th? Well, it's x squared. You just take half of the exponent. 1's a perfect square. You get plus 1, you get minus, whoops, and you get minus 1. But we're not done on this one. This is the reason why difference of squares can be tricky. We're not done here. Well, I didn't want that either. Hang on here. All right, here we go. Now, x squared plus 1. We've seen a problem kind of like this a little bit earlier in number 6. X squared plus 16. Could we could we factor the x squared plus 16? No, because of that plus sign. It would have to be a minus sign in order to factor it. That was prime. That one cannot be factored. This x squared plus 1 right here, it's very similar to that in that it's a plus sign, and because of the plus sign, it cannot be factored. But look at the other one. X squared minus 1. That's a difference of 2 squares. It can be factored. Okay, so if it's a difference of 2 squares and we have a minus sign, we have x squared is a perfect square, 1 is a perfect square. This is a difference of 2 squares. What's the square root of x squared? Well, it's x. What's the square root of 1? Well, it's 1. 1's plus, 1's minus. That thing is factored. What are we missing now? Well, we have to bring down this x squared plus 1, and now you're done. Class, I guarantee a problem like this you'll be seeing on the test. Make sure you know how this problem works here. Let's go back to page 2. Here we go. Now, let's go back to number 13. And again, you're always looking for a GCF. Between 6 and 54, there is a 6 in common. So we're going to have 6 times the quantity, and it's only one set of parentheses here, 1 minus 9x squared. Don't try to do the 2 parentheses right away. Why? Because it's this, the 1 minus 9x squared. That's what gets broken down into 2 parentheses. 1 plus 3x and 1 minus 3x. Bring down the 6, and now you're done. Number 14, 1/4 is a perfect square. What's the square root of 1? 1. What's the square root of 4? 2. What's the square root of x squared? X. So the square root of 1/4 x squared is 1/2 x. Whoops. Let's try that again. 1/2 x here and 1/2 x here. What's the square root of 16? Well, it's 4, so it goes here and here. 1's plus and 1's minus, and you're done. In number 15, what's the GCF? There's a 4 in common. There's also an x in common. We've got to take out all the GCF. So we're going to have 4x times a quantity. Well, the 4's cancel. X to the third over x is x squared minus 100 divided by 4 is 25. X's cancel. This is the difference of 2 squares. We go x plus 5 and x minus 5. Bring down the 4x, and you're done. Number 16, remember when we're factoring, we're looking for a GCF, always first. Then we need to look to see if it's in the form ax squared plus bx plus c, or a difference of 2 squares. Do we have either of these, any of these 3 in number 16? There's no GCF. In order for it to be factored as a difference of 2 squares, I need a minus sign. I don't have that. It's not in the form of ax squared plus bx plus c, so this guy's prime. In number 17, yes, 121 is a perfect square, 9 is a perfect square, but y to the 5th is not a perfect square. This one's also prime. And in number 18, is this a difference of 2 squares? Well, no, it's not. So is this one prime? Careful. What are you always looking for first? A GCF. Is there one here? Yes, there is. Factor out that 5, you get x squared minus 5. Now, is the x squared minus 5 a difference of 2 squares? No, because that 5 would have to be a perfect square in order to use it, in order to be able to factor this using difference of 2 squares. So we're done at this point. It's 5 times the quantity x squared minus 5. Well, that's it for difference of two squares. Very simple. Keep it simple. Make sure the minus sign is written between the two numbers. Factor out your GCF. One's plus, one's minus. You'll have a great time. Talk to you later. Have a good one. Bye.